Okay, now we are about to be able to learn the unit circle because we've already know what the special triangles are. So first I'm going to draw the 30, 60, 90 triangle. 30, 60, 90. Okay, so I know that the sign of 30 is 1/2, opposite over hypotenuse. And I can use the Pythagorean theorem, a squared plus b squared equals c squared, to figure out that this side is square root of 3. So then I know everything there is to know about my 30, 60, 90. Now, there are similar triangles. Similar triangles are the same shape, different size, which means that their sides are proportional. So if I wanted to draw a similar triangle, but I wanted, like, these are going to look about the same, but they're proportional. What if I wanted the hypotenuse not to be 2, but to have a value of 1? Well, I could go up to it and I could divide it by 2, but that would mean that I would need to divide every side by the same thing that I divided that by 2. So that would mean I could have a hypotenuse value of 1, but that this would be 1/2, and that this side would be the square root of 3 over 2, and this is my 30, and this is my 60. And so that did not mess up my sine value. My sine of 30 degrees is still 1/2 divided by 1, which is 1/2. And my cosine of 30 is still square root of 3 over 2 divided by 1, which is square root of 3 over 2. So you can, this is a similar triangle. And so you could do the same thing. You can say, what if I wanted my hypotenuse to be 10? Well, then I would take 2 and divide it by 5, and I multiply by 5, and I could go through and multiply everybody by 5 and get another similar triangle. You can do this with any values that you wanted to. So let's just recall our 45, 45, 90, 45, 45, 90. So I had a 1, a square root of 2 when I developed this one. But I'm going to do the same thing. What if I wanted my hypotenuse to be 1? And I do. I'll go through and I'll divide this side by the square root of 2, and this side by the square root of 2, and this side by the square root of 2 to get a similar triangle that is proportional. My hypotenuse is 1. This side is 1 over the square root of 2. This side is 1 over the square root of 2. And this is my 45, 45, 90 triangle. And again, you could do that if you wanted to change it to a different value, but I wanted it to be 1. Why did I want it to be 1? Because we are about to learn the unit circle. Unit means 1 unit. And we call it that because the radius of the unit circle is 1. So I have a couple of unit circles here, 3 on this page. First, we're going to look at this one. If the radius of this circle is 1, and I go out this far to this point, what would be the coordinates of this point if this is my x-axis and this is my y-axis? Well, the coordinates of this point would be 1, 0, because I went 1 to the right and then I didn't go up or down. And what would be the coordinates of this point right here? This would be 0, 1. And this would similarly be -1, 0. And this would similarly be 0, -1. Those would be the coordinates of those points. Okay. Now, these are also angles. This is angle 0 degrees. This is the angle 90 degrees. This is the angle 180 degrees, and this is the angle 270 degrees. I want us to keep that in mind, okay? I might need more room, so I'm going to write this out here. All right. Now, let me take one of these triangles. In addition to these little things we were just looking at, let me take the 30, 60, 90 triangle, and I'm going to impose it. I'm going to put it inside of this circle. So I'm going to draw 30 degrees. And I'm going to go down here. And this is my right angle. And this is 30 degrees. And this is 60 degrees. And this is 90 degrees. So what I know is that if this is at the center of my circle and this went to the edge of my circle, that this length is 1. And so I also know that this length is the square root of 3 over 2. And I also know that this length is 1/2. So the coordinates of this point right here on the circle, if I go right this far, this is my x value. My x value here is the square root of 3 over 2. And my y value is this length, and this is a 1/2. Okay. Now, what if I decided I wanted to put a 60-degree triangle in here? I can do that too. So let me just, this is getting a little messy. I'm going to use this other one. Let me go up 60 degrees. From here to here is 60 degrees. And then I'm going to draw this down. And this is my 90. And this is 30 degrees. All right. So what I know about a 60-30 is that this is 1/2. And this is the square root of 3 over 2. And this is the center to the edge of my circle. This is still a 1. And why did these get switched? Because I just drew this, but I just rotated it. I flipped it and stuck it up here. So the sine of 30 is 1/2. And the cosine of 30 is square root of 3 over 2. And the cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. So I could draw it this way. And that tells me that this point right here would have the x coordinate 1/2 and the y coordinate square root of 3 over 2. So if I draw that over here, oh, that I didn't draw that very good. Let me make it there. That's a little bit better one. Those would have the x coordinates 1/2 square root of 3 over 2. So those got a little bit reversed. That's what they should be. What if I decide to put the 45, 45, 90 in? So just so that we have more space, I'm going to erase this part and put the 45, 45, 90 in. Let's do that guy. All right. That one's going to go straight in the middle. And we know that if this is the unit circle, that the radius is 1, because that is from the center to the edge of the circle. And so this is 1 over the square root of 2, and this is 1 over the square root of 2. And this is 45. And this is 45. And so we know that the coordinates of this point is this x value, 1 over the square root of 2, and the coordinates of this value is 1 over the square root of 2. All right. That's good stuff. So let's go down to our unit circle. This is it, the full-blown unit circle. So let me show you the important angles. The important angles are go in factors of 30 degrees and 60 degrees, and also in 45 degrees. And also we'll talk radians in just a minute. But first, let's just look. Let's fill in this. Because what you're going to see, and I hope you can already see that, is that in this unit circle, the sine of whatever angle we had is equal to the y value. The sine of 30 degrees is equal to 1/2, which is the y value right there of this point on the circle. And the cosine of whatever angle this is, let's look at the 30 degrees, is equal to the x value. So the x coordinate of these points are the cosine of that angle, and the y coordinates of these points are the sine of these angles. That is true on our unit circle. So right here we go. I like to begin my unit circle by first marking up all of the important angles. So we're going to go in degrees right now. 0 degrees right there. Plus 30 is 30 degrees. Plus 30, skip the middle one, is 60 degrees. plus 30 is 90 degrees. Plus 30 is 120. Plus 30 is 150. Plus 30 is 180. Plus 30 is 210. Plus 30 is 240. Plus 30 is 270. Plus 30 is 300. Plus 30 is 330. Plus 30 is 360, which is coterminal with 0. Those are the important 30 and 60 angles. Now let's go through and do the middle ones, which is the 45. So 0 plus 45 is 45. Plus another 45 lands us at 90. Plus another 45 lands us at 135. Plus another 45 is 180. Plus another 45 lands us at 225. Plus another 45 lands us at 270. Plus another 45 is 315. Plus another 45 lands us at 360. So those are all the important angles on our unit circle. Now, we're going to go through and label the XY coordinates. So at 0 degrees, we look at this point on a circle with a radius of 1, and we realize that this is 1, 0. Up here, we've already done this. We realize that this is 0, 1. Over here, we realized that we had to go -1, 0. Down here, we had to go 0 for the X and -1 for the Y. So we got these are called the quadrangles, and we got those labeled. So let's just tell you the importance of after, we're going to label all of the XY coordinates, but what this is going to give us is this important information. If I say, hey, what is the sine of angle 0 degrees? What we're going to do is we're going to look at the Y value of the point at 0, and it's going to equal to 0. And we say, what's the cosine of 0 degrees? We're going to look at the X value of angle 0, and it's going to be 1. What if they say, what is the sine of, let's see, of 270 degrees? Well, that's the Y value of 270. That's -1. What is the cosine of 270 degrees? That's going to be the X value of this point, and that's 0. We're going to be able to do that for all of these, and it's going to be real quick and easy. And these are the angles we want to be real smooth with. Let's take note of the quadrant. This is quadrant 1. In quadrant 1, this has this positive, negative. I'm just going to write it like this. X is positive, Y is positive in quadrant 1. In quadrant 2, this is quadrant 1. In quadrant 2, X is negative, Y is positive. In quadrant 3, if we were going to put a point right there, X is negative, Y is negative. In quadrant 4, if we put a point in here, X is going to be positive, Y is going to be negative. Okay, so that's what those are for. Let's go do our 30. We already drew this 30, 60, 90 triangle, and we already figured out that his coordinates are square root of 3/2, 1/2. So that means the X is the square root of 3/2, and the Y is 1/2. We did 60. We figured out that this guy is 1/2. And that Y is the square root of 3/2. You can go back and do this, you know, the way we did it before until you get real smooth at it. And you're like, oh, this is what this is. 45, we could superimpose this triangle on here, and it's here. And we say, oh, this is a 1 square root of 2. And we could divide everybody by square root of 2. And this we'd see that the sine and the cosine are both 1 over the square root of 2. That's what we get right there. So these are the coordinates for these guys. Now, let's talk about reference angles. What is the reference angle for 150 degrees? Well, let's just have a look at this. I'm going to do it for this one, and I think you're going to see how it's going to go for all of these. It's this much. And how much is this? It's 30 degrees between here and here. Do you know what that means? That means that the sine of 30 degrees is equal to the sine of this 30 degrees. So we can use the reference angle of any angle, its sine, cosine, tangent of any angle using the reference angle, it will be the same. So the sine of 30 degrees, we already know is 1/2. And the cosine of 30 degrees is the square root of 3 over 2. See, these are going to be the same. But how do we have to adjust this? Because this wasn't 30 degrees, it was 150 degrees. We have to adjust it by the quadrant. So we're in quadrant 2. That means that this is going to be a negative x. That's what we have to do there. Let's go again. What if we were doing the 120 degrees? Well, look here. What is its reference angle? Its reference angle is 180 minus 120. It's this right here, which is 60 degrees. And we already know that the cosine of 60 degrees is 1/2. This is a 1/2. And the sine of 120 degrees is square root of 3 over 2. And so we can use the same reference angle information, but we have to adjust it for the quadrant. The quadrant is 2, so that means this is going to be negative. Let's go for 135. This is a 45. The x and y values are 1 over the square root of 2, 1 over the square root of 2. And we have to adjust it for the quadrant. This is negative. Now, let's look here. Let's do 210. His reference angle is going to be 30 degrees. So you can do reference angle 30 degrees, but I'll tell you how I stuck this in my mind. When I first learned the unit circle, I said, what are the values that keep showing up? Square root of 3 over 2 and 1/2. That always shows up for a 30-60 angle. So the bigger value is square root of 3 over 2. So if I look at 30 degrees, the x value is bigger, the y value is smaller. So I put the bigger value in the x and the smaller value in the y. Look at 60. It's got the same values, only they're switched. So in my mind, I was just like, hey, this point right here, to get to the x, it was shorter, longer. So I put the bigger value in the y and the smaller value in the x. You can do this however it makes sense to you. You can do it by reference triangles. You can say, hey, these are the values that keep showing up. You can do it by symmetry. Like if you fold this circle over, you're going to see these values match. You just adjust it for, if you fold this down, these values are going to match. And you can see that they are just adjusted for the quadrant. So for 210, I'm going to say, oh, x was big, square root of 3 over 2. Y was short, 1/2. I'm going to say for this guy, for 240, x was short, y was longer, square root of 3 over 2. I'm in quadrant 3, so everybody's negative. What about the 225? It's always 1 over the square root of 2 because the reference angle is 45, but we're in quadrant 3, so those are negative. What about 300? X is short, y is long. X is short, y is long. Look, what about 330? X is long, y is short. But we're in quadrant 4, so that means x is positive, but y is negative. Adjust the sign. This middle one is always a 45, so it's 1 over square root of 2, 1 over square root of 2. But x is positive, y is negative. So if you look at you're going to see symmetry all over the place. If you can figure out one quadrant, and you can, then you can see that if I folded this over, the values are the same. Or if I folded this whole thing down, the values are the same. There's tons of symmetry going on. How does this help us? Like this. Somebody like me is going to say, what is the sine of 150 degrees? And you're going to have to answer it real quick. If you have this unit circle filled out, here's 150 degrees, and here's the y value, and that's what the sine is. It's 1/2. You're going to see it just like that. Or if they say, what is the sine? What is the cosine of 225 degrees? Well, here's 225, and the cosine's the x, so it's going to be -1 over the square root of 2. This is what's going to help us know values really quickly by getting used to this. Now, the only thing we have left to do is talk radians. So this is what we're going to do. 30 degrees. If I convert it to radians, will give me pi over 6. So I'm going to go around and label my important angles again. So I guess I'll do this in red just so we can see it difference. Okay. So these other blanks are for radians. 0 degrees is 0 radians plus pi over 6 plus another pi over 6 is 2 pi over 6, but that can be simplified to pi over 3. Oh, let me do the quadrangles. I should have done that. If I go here and I go all the way around the circle, that is 2 pi. If I go halfway around the circle, that is pi. If I go halfway between 0 and pi, that is pi over 2. So 0 plus pi over 2 lands me there. That's 90 degrees. Plus another pi over 2 is 2 pi over 2, which can simplify to be pi. That's here. Plus another pi over 2 would be 3 pi over 2. Plus another pi over 2 would be 4 pi over 2, which is also 2 pi. Okay, those are the quadrangles. Now let's do the 30, 60, 90. I mean the 30 degrees. 30 degrees is pi over 6. So 1 pi over 6, 2 pi over 6 simplifies to pi over 2, pi over 3. 3 pi over 6 is the same thing as pi over 2. 4 pi over 6 would land me here, but 4 pi over 6 can be simplified to 2 pi over 3. Plus another pi over 6 would be 5 pi over 6. Plus another pi over 6 would be 6 pi over 6, which is pi. Plus another pi over 6 would be 7 pi over 6. Plus another pi over 6 would be 8 pi over 6, but that can simplify down to 4 pi over 3. Plus another pi over 6 would be 6 pi over 6, but that can simplify down to 3 pi over 2. Plus another pi over 6 would be, let's see, was that? No, let's see, that was 8 pi over 6. This is 9 pi over 6, would be 10 pi over 6, but that simplifies down to 5 pi over 3. Plus another pi over 6 would be 11 pi over 6. Now, if you don't like doing it that way, that is fine. You can take 330 and just convert it to radians by multiplying by that, and you'll get 11 pi over 6. That's another way to do this. Now, I'm going to go around and get the 45s. 45 degrees, if I convert it to radians, will give me pi over 4. So 0 plus pi over 4 is pi over 4. Plus another pi over 4 lands me here, and that's 2 pi over 4, which can simplify to pi over 2. Plus another pi over 4 can land me here, which is 3 pi over 4. Plus another pi over 4 is 4 pi over 4, which is pi. Plus another pi over 4 is 5 pi over 4. Plus another pi over 4 is 6 pi over 4, which is this simplifies to 3 pi over 2. Plus another pi over 4 is 7 pi over 4. Plus another pi over 4 is 8 pi over 4, which simplifies to 2 pi. So this is your unit circle filled out. And so you're going to get really good at filling this fella out. And it's going to be very helpful because you're going to have to answer things like this. What is the cosine of 7 pi over 6? And if you have this filled out, here's 7 pi over 6, and the cosine is the x value. So that is the unit circle.